The dashed line of the figure shows where a cut is to be made in a rectangular piece of sheet metal. Find the length of the cut. So it looks like we have a piece of sheet metal that measures 18 inches by 28 inches, and we're wanting to make a cut so that we're intersecting this edge 12 inches from the corner, and I guess this one we don't know. Okay, this is actually asking us two different things, it looks like. We're going to need to figure out what x is, so I don't know what distance that's going to be. And we're also trying to figure out what the length of the cut is, this distance right there. So I'm going to end up finding both of those things. I suspect I'm probably going to have to find the x, or at least it'll be pretty easy to find once I know y, or once I've gone through finding y. In any case, this is a 30, 60, 90 triangle, and I know that when I have a 30, 60, 90 triangle, I know that there's a certain ratio between the sides of this triangle. So the shortest one, the leg that's opposite the 30-degree angle, has a unit measurement of 1, or if I use that kind of as my base measurement, let's call this, I don't know, I know I'm using a lot of variables here, but I'm going to call this z. In my example before I used x, but I can't use x again because it's right there. So I'm going to call this z. This one will be 2z. So maybe instead of calling that y, I'll just stick with 2z. And then this one over here would be z times the square root of 3. That's what we see when we have a 30, 60, 90 triangle. The side that's opposite my 30-degree angle is kind of the base length. The hypotenuse is twice that, and the other leg is the square root of 3 times the base angle, the base side. Okay, so I know that much. Is there anything else I can figure out? Well, actually this measurement right here, I know that this distance right here, well, this up here is 12 inches, and in total we should have 28 inches. 28 minus 12 is 16, so that means this distance right here must be 16 inches. Okay, well, now that I know that, you can see it actually set up a little equation here. I can use that to figure out what the value of z is. If I know z times the square root of 3 is equal to 16, that means z is equal to the square root 16 divided by the square root of 3, just dividing both sides of that equation by the square root of 3. 16 divided by the square root of 3 gives me 9.2376. 9.2376 approximately. Okay. So that's this distance right here, 9.2376, and the distance of the cut, actually we can figure that one out really easily. That's just 2z, which is 2 times this number. We have 18.4752. So the length of the cut, this length right here, that should be 2z, it should actually end up being 18.4752 inches long. Now, why would you need to know the length of that cut? Maybe you're paying to get this cut, and whoever's cutting it is charging you by the inch. So you're trying to figure out how much it would cost to get this particular piece of metal cut. Or who knows? I'm not exactly sure why you'd need to know that. The other one, so there is an x here. We don't know what that measurement is. Let's go ahead and figure that one out, even though it's not explicitly asked for on this problem. It's relatively easy to figure out what x should end up being, though, because we already know that this distance right here is this z. It's 9.2376. And in total, this total distance from here to here should be 18 inches. So x would end up being 18 minus 9.2376. And I'm going to go ahead and say that it looks like this is not drawn to scale very well, because this is almost going to be the same. You know, this should have been about the halfway point, but oh well. Let's see. I'm doing 18 minus 9.2376, which gives me 8.7624. So this was the distance, the length of the cut. That's that length right there. And x was this one right there. So I found the two measurements I was looking for in this problem. In this next example, we have a cathedral ceiling creates the interior wall shown. So you have your ceiling up here, Maybe this is some sort of interior wall. This is maybe the exterior wall out here. You have a window or something like that. You can kind of envision. We're trying to figure out what is the length from here to here. This is saying because we need a beam to go along that wall, and I suppose you would need that. Although you'd probably, well, whatever. I'm not sure exactly how you'd figure that out. But how we're going to be doing it is, well, we know that this distance here is 8 feet, that distance there is 12 feet, this is 22 feet. Those are the only measurements we know, other than the fact that we know that these are perpendicular. So actually this is a trapezoid that it forms. Although I'm not going to be using anything about trapezoids here. What I'm going to do is I'm going to say, okay, well, I would like there to be a right triangle somewhere in here. So if I was to come along here and draw in that parallel to the ground, parallel to this line on the ground, then you can see what ends up happening. Well, this part right here would end up being 8 feet, and that means this part up here would end up being 4 feet, because in total it needs to be 12 feet. And this length right here is 22 feet. So what I've done is I've created a right triangle, and I know 2 of the measurements of that right triangle, and it looks like it's the hypotenuse that I need to find. So that means y squared is equal to 4 squared plus 22 squared. Thus y must be the square root of 4 squared plus 22 squared, which gives me square root of 4 squared plus 22 squared, which gives me approximately 22.36 feet.